Okay.
Hi everyone, this is day one of eOTF second session, and thanks to OIP Labs Ramanujam for the collaboration, and we are committed to the connected intelligence going forward. And sorry, this looks like this is the one. So we have here OpenShift and sensor networks with Promateus, and Trinath was not able to join. However, he is one of our stalwarts from Hyderabad. Just to introduce him, he is currently working with F5, and he is working on the networking portion of it. And he has been there from the beginning of eOTF, at least 4 years back when he started his OTF. 4 to 5 years, I think, 5 years. And he is one of those community players who started with OPNFE, and is accomplished and product manager at F5. Then we have Digambar Patil, who has joined. He has a industry experience of 10 plus and 8 plus in the technical. This is 2 years back, I believe, but he is more than 12 now. He has broad knowledge about the OpenStack, and he was part of the Dell team for implementation of the bare metal along with Kubernetes. He was one of those early adopters of Kubernetes, and has done several projects, and also part of the team now currently at Microsoft, and he is an expert in Python, Go, and various. So before I go to the Digambar, the part which was presented by Trinath Somanchi, I just browse through quick. So what we have is a OpenShift is an enterprise Kubernetes platform, and you can build, deploy, and then scale and manage. That's the main theme behind this. And what one can do is we can just review what it is before we move. Yeah, here we go.
Want to propel your innovation cycle, improve customer experience, and gain competitive edge? Then you need agility with the way you build, deploy, manage, and scale software applications anywhere. To overcome the challenges of transforming legacy apps and develop new cloud-native apps, you need a Kubernetes-powered hybrid cloud application platform that can provide software developers, data scientists, and data engineers with self-service, secure access to their favorite development tools, frameworks, and data, and can handle any application in a consistent way across any location. Red Hat OpenShift is the Kubernetes-powered hybrid cloud application platform with capabilities to enable DevOps, giving you everything you need to quickly and securely build, deploy, manage, and scale any traditional or cloud-native application in a consistent way across any environment. Imagine being able to automatically deploy and update a database of your choice with the same ease as installing a smartphone application, or any of the app dev, AI, data analytics tooling, and more. OpenShift's deep integrations with our ecosystem partners and open source community projects using Kubernetes operators allows you to automate and simplify deployment, scaling, and lifecycle management of any workload in a consistent way across any cloud directly from within OpenShift, giving your teams more time and freedom to innovate faster. Red Hat Marketplace takes this one step further by helping simplify procurement and deployment of enterprise software on OpenShift anywhere. Red Hat Open Innovation Labs helps transform legacy apps and on-ramp new applications on OpenShift. Around the world, OpenShift is providing agility and empowering organizations to develop and run all kinds of applications. It's allowing manufacturers to be more productive. It's helping businesses to improve customer experiences. It's even enabling rapid detection of life-threatening conditions to save lives. Red Hat OpenShift is leading the way to a simpler, more consistent Kubernetes-powered hybrid cloud application platform, helping accelerate build, deploy, manage, and scale any application in a consistent way across hybrid clouds. The end result is faster innovation, improving customer experience, and gaining competitive edge. Learn more. Contact us today.
So we have seen enterprise Kubernetes platform, and generally Kubernetes platform is key for several projects, and most of the projects I would put it. But that's not the only option. There are several options, and many Linux distros are there which are supported, and so are Windows and all. So, or Azure, I would put it. So, what was interesting about Kubernetes from Trinath's point of view is on the F5 networking, because F5 is a load balancer company from Seattle, and they have been in this business for even before Kubernetes. And they have two major products. One is the NGINX, the what you call the web servers, which was a free available open source, and the other is obviously they have got their hardening on it. There is another product called Big IP, which is nothing but a what you call the box which is used for load balancing various workloads, and it uses some control language, and it works on the cluster, Kubernetes cluster. So those are the two main. Most of the work which Trinath has been pointing is working on this container network interface. Kubernetes as such as a container platform has a CNI requirement. That is, you need to have container network interface, which is standard to facilitate communication between the pods, and that is in the container. So container networking requires that. And so this can be done through various options like cluster IP, node port, host port, load balancer. These are the various ways to tweak the performance. So at the cluster level, so target cluster, Kubernetes itself comes with a master and which is a system cluster, and then you have the target cluster, which is a workload cluster. So usually they are in a cluster, and so a cluster where you create the pods and all can be accessed through host port, node port, and these are the concepts which are used. Plus, besides that, there is an ingress resource type which is useful for L7 content routing and all. So these are the things which are managed by the Big IP, as well as plus for the HTTP traffic, one uses the NGINX as per the F5 formula for success, and they have whatever called support for the drivers for the CNI like Flannel and Calico, using VXLAN and BGP, which are the protocols, and ingress service is what they use for automating with Big IP. So that's all as far as Kubernetes F5 portion of the NAT is there. Hope if you want more detail, you can connect to him. And with that, I will hand over to Digambar. Digambar, floor is yours.
Thanks, Prakash. Hello, everyone. It's nice to be here in this group, and so already Prakash given an introduction about me. So I will start on the topic itself because I don't have much time next 10 minute time to join another call. So Promateus is a monitoring tool which Kubernetes uses across its all sub projects or in CNCF ecosystem. So it's a CNCF project, not Kubernetes, because CNCF has multiple projects and it is one of the world recognized one across the domains. So, why we need Matrix and everything? Because when this project came into picture, because we have pods, we have systems running, we have nodes running, and every system we need to know and trace if something fails, what it fails, if service going to get failed. So how do we know? Okay, and based on to generate, to get the alert, to get the query, to get the data and metrics, and based on that we do some calculations, and we post that to a Grafana or any other tool, uh, and we demonstrate that these are the things which we need to take care of, and this is how we are getting metrics. So there are push notification and pull notification. So how it works, in Kubernetes, there are multiple pods or nodes where we annotate, though we annotate, add annotation, Prometheus annotation. That's how the service exposed to the outside. So for that, we have to use the exporters. Okay. So what exporter does? Okay, exporter actually listens on the port and pull the metrics of that service. Okay, and each exporter is responsible for each project. Let's say we have a kubeword, so kubeword exporter is needed. We have a node, so node exporter is needed. So whatever the matrix you want to pull from respective project or whichever the project, we need to add exporter. Otherwise, you only installing Prometheus doesn't work. So Prometheus is kind of exposing those matrix to the web or any other UI. So, but we have to, these are the exporters which actually taking care of talking to the service and pushing those data to them via Prometheus. Okay. So in the future, we will have telegraphs and other things will come into picture, but that's how it works. Okay. So there is a jobs and exporter you see, and Prometheus server, which is exposing data to the UI. And here you can see the server which has storage, PromSQL. PromSQL is a kind of query language, which is used to display and query the data from the server. So let's say I want to pull the data from keyword matrix related to VMI and others. So we will use PromQL, and we will display all the data. Let's say we want to display query the node matrix. So we will query those into the QL. So PromQL has insights, pod kind of queries. So you can respective container queries and all those. It is defined by containers. It is actually those things whichever the query language provides. So query language is nothing but SQL kind of thing. So kind of SQL is also a query language where we have tags, sections, and sessions and other things which we can use, and then query the data from the database. Okay, so where those data is stored, so PromSQL uses its own persistent DB or other things, databases where this data is stored, and retrieval happen through the exporters and PromQL servers. So once the PromQL data gets the data, that query data will be populated into a dashboard. Either it's a prom dashboard, Grafana, or web UI. So wherever we use from Grafana, we also do those queries from some Grafana languages there also. So from there we can pull the data and put it on the Grafana, or we can have our own dashboard. So this is a matrix where we are displaying in Grafana. But where are the alerts? Because alerts are the things which people get notification via email, via alerting tools like dashboard. You will see the alerts. So those alerts will be displayed. Let's say I want to configure the alert where the threshold I want to set, and that threshold is actually whenever we go and hit the threshold, so server hit, or that one of the service hit that process that threshold, it will get query that threshold that alert is generated and pushed to the email notification created and updated to the user. This is kind of automatic thing happens because in case of Matrix, we usually don't see, because if you go and particularly see on the database, sorry, on the Grafana or UI, then and then only you will get to know. But in case of alerts, people get notifications automatically. That's kind of push notification it does. Okay, so so these are the things I see, which is Prometheus is making more or bringing more logic and more usefulness in the Kubernetes, so that it is a widely used across all the services, all the projects, and it is one of the project which is used horizontally across all the vertical domains. So I think that's a short introduction I can say here. And you can see here that there is a Linux VM, MySQL, C groups. These are kind of a northbound, southbound things we use here, and the northbound is API server, web apps, which kind of pods and other things which is used. But you can see that Prometheus is actually used across all these southbound or east picture, which southbound or northbound is, and the service discovery it does against DNS and console and AWS. But in case of copy, we have multiple cluster providers, and we need to add annotations so that those providers should also expose. But based on the cloud providers, it is supported. Currently, I didn't get chance how it work in case of copy, but I believe that when we annotate those things and have an exporter for those, I think it should work across all the copy providers. I think that's it from my side. Maybe next time I'll give more in detail introduction about how to develop a node exporter or custom Prometheus exporter, how we can use it, how we can ship it, and how it will be displayed data on across all, pull the data from this Kubernetes. So in a development environment, maybe that can be covered next time. So that's it from my side. I'll over to Prakash.
Hey, thank you, Digambar, for the quick this one. One mention I forgot to is TSDB, that is the time series database is used and numerical data is collected. And if you want something long term or accurate, then you must use a Zabbix like thing rather than Prometheus. So this is one of the takeaways from this, and hopefully this is what we have for this session. We'll move on to the next session. And